There is a sign posted at the edge of our solar system written in a language that all beings on all worlds must eventually learn to read. It is not a sign made of matter, nor is it a warning broadcast on any frequency. It is a sign woven into the fundamental mathematics of the universe, a permanent and non-negotiable ordinance displayed in the silent, unforgiving courtroom of physical law. The sign is simple. It says, "No entry." For 100,000 light years in every direction, across the entire sprawling expanse of our home galaxy, the same sign is posted at the border of every star system. It is a galaxy-wide quarantine, a state of permanent and enforced isolation. We are a species that has just learned to look up and dream of other shores, and we have discovered to our dawning collective horror that the ocean between them is not just uncrossable but is designed to be uncrossable. The space between the stars is not a frontier waiting to be explored. It is a wall. This is the great and terrible door slam that lies at the heart of the Fermi paradox. For decades we have been haunted by the great silence from the stars, asking the question, where is everybody? We have imagined 1,000 complex and dramatic answers, that they have all destroyed themselves in nuclear fire, that they are hiding from us in a paranoid dark forest, that they have transcended to a higher plane of existence, that we are living in a cosmic zoo. But the simplest, most direct and most scientifically supported answer is one we have been strangely reluctant to accept. The answer is that the silence is not a mystery of sociology, but a simple fact of physics. The reason no one visits us is the same reason we will never visit them. The door is locked, the key does not exist. The very laws that allow stars to shine, that allow planets to form, that allow life to evolve, are the same laws that build the walls of our prison, ensuring that life once born stays where it began. Our dreams of galactic empires, of star-spanning federations, of a bustling cosmic community are a beautiful and a deeply human fantasy, born from our own terrestrial history of exploration and expansion. But the universe does not operate on the principles of human history. It operates on the principles of Albert Einstein and Konstantin Tsiolkovsky, and their cold, hard, and unforgiving equations paint a picture not of a hopeful frontier but of a permanent and profound confinement. Interstellar travel is not merely difficult. It is not an engineering challenge waiting for a more advanced civilization to solve. For all practical and meaningful purposes, it is a fundamental impossibility, a beautiful dream that is systematically and brutally shattered by the very nature of reality itself. The great silence is the sound of 1 billion other civilizations on 1 billion other worlds, all coming to the same bleak and unavoidable conclusion. The stars are beautiful, but they are not for us. The galaxy is a collection of lonely, isolated islands, and the journey between them is a voyage that is forbidden by the gods of space-time, energy, and mathematics. The first, the highest, and the most absolute of the great walls that enclose our cosmic island is not constructed of matter or of energy. It is woven with a perfect and an unforgiving mathematical elegance into the very fabric of space-time itself. It is the ultimate cosmic speed limit, the law that governs everything and pardons nothing, the speed of light. This number, represented by the deceptively simple letter Chris, is the most famous and most consequential constant in all of physics. It is a velocity of approximately 300,000 kilometers per second, a speed so incomprehensibly extreme that a particle of light can circumnavigate the entire circumference of our planet Earth more than 7 times in the brief and fleeting instant of a single human blink. For most of our history, we intuitively understood speed as a limitless and an incremental quantity. If you wished to go faster, you simply needed to push harder to build a more powerful engine to apply a greater force. There was no ultimate finish line in the race of velocity, no final and insurmountable barrier. Then, in the quiet solitude of a Swiss patent office in the year 1905, a young, and then unknown physicist named Albert Einstein systematically and permanently dismantled that intuition forever. In his theory of special relativity, he revealed to the world that Krap is not merely a speed at which light happens to travel. It is a fundamental and an axiomatic property of the universe's underlying operating system. It is the speed of causality itself. It is the absolute maximum velocity at which any information, any interaction, any influence, any effect of any kind can propagate from one point in space to another. It is the universe's own internal processing speed, and nothing, absolutely nothing, can outrun it. The reason for this ultimate and inviolable speed limit is as elegant as it is profound. As an object that possesses mass is accelerated, its kinetic energy increases. This is a simple and intuitive fact of our everyday experience. But Einstein's most famous and most beautiful equation, E=mc², revealed that mass and energy are not separate and distinct entities. They are two sides of the same fundamental cosmic coin, interconvertible forms of the same underlying substance. As you pour more and more and more energy into an object to accelerate it, some of that energy is converted into motion, into velocity, but a portion of that energy is also and unavoidably converted into mass. The object literally gets heavier, more massive as it approaches the speed of light. This increase in what is known as relativistic mass is utterly and imperceptibly negligible at the speeds of our daily lives. But as you get closer and closer to C, the effect becomes dramatic, then overwhelming, and then finally infinite. To accelerate a single grain of sand to 99.999% of the speed of light would require a colossal but a finite amount of energy. But to make that final, that infinitesimal, that last desperate push to reach 100% of the speed of light would require a truly and a literally infinite amount of energy, because at that precise and forbidden speed, the grain of sand's mass would have become infinite. It would contain the entire mass energy of the observable universe. The cosmos itself, through its own beautiful and internal logic, forbids such a profound and a nonsensical absurdity. It is absolutely crucial to understand that this is not a technological problem that is awaiting a future and a cleverer solution. We cannot invent a new and a more powerful engine that can break the light barrier any more than we can invent a new and a more clever form of geometry, where the interior angles of a simple triangle add up to 500 degrees, or where a circle has 3 sides. It is a fundamental, an axiomatic, and an unchangeable law of the reality that we inhabit. The speed of light is not a goal to be reached. It is an asymptote, a mathematical limit to be forever and tantalizingly approached, but never ever touched. It is a great cosmic horizon that recedes from us at the very velocity with which we attempt to chase it. This single, immutable, and experimentally verified fact of nature is the first and the most decisive nail in the coffin of our interstellar dreams. It establishes the fundamental and the non-negotiable timescale of any potential journey. It means that the voyage to even the very nearest of our stellar neighbors is not a matter of weeks or of months, as our science fiction has so optimistically and so misleadingly led us to believe, but a journey of many, many years at the absolute theoretical minimum. The journey to the center of our own galaxy, a place we can see with our own eyes as a faint glowing band of light in the night sky, is a journey of 25,000 years, one way, with no exceptions and no appeals. And the journey to our nearest galactic neighbors, the great and beautiful spiral of Andromeda, is a journey of 2.5 million years, a span of time so vast, so profound, and so utterly inhuman that the species of Homo sapiens did not exist when such a journey would have had to begin. The universe, in the very first and most fundamental clause of its operating manual, has declared that its constituent and widely scattered islands of matter will remain forever and irrevocably separated from one another by uncrossable and silent oceans of time. The immutable and absolute speed of light erects the first and the greatest wall of our cosmic prison, a wall of pure and unforgiving time that defines the sheer, the soul-crushing, and the mind-numbing duration of any potential interstellar voyage. But even if we were to accept this grim and this difficult reality, even if we were to resign our species to the strange and the melancholy fate of multi-generational odysseys that last for centuries, for millennia, or even for tens of millennia, we would then immediately and violently crash headfirst into the second Great Wall, a barrier not of time, but of brute force, and of almost unimaginable energy. This is where Einstein's most famous equation, E equals mc squared, returns to haunt us, not as a beautiful and an abstract theoretical limit on our ultimate velocity, but as a practical, a brutal, and an utterly insurmountable economic problem. The energy required to accelerate any macroscopic object to a significant and a meaningful fraction of the speed of light is not just large. It is an amount of energy so stupendously, so astronomically, and so civilization-endingly vast, so far beyond our current or any conceivable future industrial and technological capabilities, that it pushes the entire and beautiful concept of interstellar travel from the realm of difficult and challenging engineering into the realm of pure, of unadulterated, and of almost laughable fantasy. Let us perform a simple, a conservative, and a deeply sobering back-of-the-envelope calculation to illustrate the almost comical scale of this impenetrable energy barrier. Let us first consider a modest and a humble proposal, not a giant, a city-sized, and a self-sustaining colony ship carrying thousands of hopeful human souls, but a small, an unmanned, and a purely robotic probe with a total mass roughly equivalent to one of our own historic Voyager spacecraft, a few thousand kilograms. And let us set a seemingly modest and a reasonable goal to accelerate this small and simple probe to just 10% of the speed of light. This is a velocity that, while impressive by our current terrestrial standards, would still require a long and a patient 43-year journey to reach our very nearest stellar neighbor, the small dim red dwarf star of Proxima Centauri. The kinetic energy required to achieve this seemingly modest speed can be calculated with simple high school level Newtonian physics. The number that emerges from that simple and straightforward calculation is a monster. It is a figure of approximately 200 quadrillion joules of energy. This is a number so vast and so far removed from our everyday experience that it is effectively and functionally meaningless without a familiar and a human-scale context. So let us provide one. This amount of energy is equivalent to the entire, the combined, and the global energy consumption of all of human civilization, from every power plant, every car, every factory, every home, and every light bulb on the planet Earth, for more than 3 full and uninterrupted days. This is the staggering, the almost unbelievable, and the deeply sobering energy cost to launch one single small one-way robotic probe on a 43-year trip to the very nearest star. Now let us scale up our ambition. Let us imagine the archetypal and the beloved vessel of our science fiction dreams, a great generation ship, a vessel large enough and robust enough to carry a few hundred human colonists, and the incredibly complex closed-loop and perfectly self-sustaining ecosystem that would be required to keep them and their descendants alive for centuries of lonely and difficult travel. Such a ship, let us call it the Ark, would need to have a mass of at least 1 million tons to be even remotely and theoretically feasible. Let us again set our modest and our patient goal of accelerating this great arc to just 10% of the speed of light. The energy required to accelerate this vessel to that speed is not just larger, it is catastrophically, it is civilization-endingly, and it is almost comically larger. It would be an amount of energy that is equivalent to the entire energy output of the entire human race at its current levels of production for more than 5,000 years. To build and to launch a single such vessel would require humanity to dedicate its entire industrial, its entire economic, and its entire energy infrastructure for the entire and complete span of its recorded history, from the very first Sumerian cities to the present day, to this one single monumental and all-consuming project. It is an investment so disproportionate, so completely and totally all-consuming that it transcends the realm of economics and enters the realm of the absurd. And 10% of the speed of light is, in grand galactic terms, a pathetic, a leisurely, and an almost useless crawl. It still means a journey of 10,000 years to reach a star that is just 1,000 light-years away, a tiny, an insignificant, and a next-door neighbor fraction of the distance across our own vast galaxy. What if we wanted to go faster? What if we, in our hubris and our ambition, aimed for 90% of the speed of light, a velocity that would finally and truly allow for journeys across the local stellar neighborhood in a matter of a few human-scale decades rather than in deep, inhuman millennia? Because of the strange and the beautiful and the unforgiving effects of special relativity, the energy requirements for acceleration do not scale linearly with velocity. They scale exponentially. The energy needed to get our 1 million-ton arc to 90% of C would be an amount of energy that is equivalent to the entire, the staggering, and the almost unimaginable energy output of our own sun itself for several continuous minutes. It would be an amount of energy that is comparable to the brilliant and the terrifying detonation of a supernova explosion. A civilization would have to achieve complete, total, and perfect mastery over the entire energy output of its own parent star to become a true and a glorious Kardashev type. Two civilizations simply to launch a single, a one-way, and a relatively short-range voyage to a nearby destination. The great and the terrible energy wall, a wall that is constructed by the simple, the beautiful, and the elegant physics of E equals mc squared, is so high, is so steep, and is so utterly and completely insurmountable that it effectively makes the price of a single ticket to the stars, the price of a star itself. No sane, no rational, and no intelligent civilization, no matter how advanced and no matter how powerful, would ever pay such a ridiculous and such a self-defeating price. They would look at the staggering and the almost comical bill, and like any sensible and rational economist, they would immediately and without hesitation conclude that there are far better, far more efficient, and far more meaningful ways to spend the entire and the precious energy of a sun than to fire a tiny, a fragile, and a lonely metal can across a vast and an empty void. But the long and the terrifying horror story of interstellar economics and of fundamental physics does not end with the brute force and the almost unimaginable energy requirements. It is compounded, it is amplified, and it is made even more impossible by a third and perhaps a more insidious, a more elegant, and a more intellectually beautiful barrier, the absolute and the unforgiving tyranny of the rocket equation. Formulated by the brilliant, the visionary, and the tragically underappreciated Russian scientist Konstantin Tsiolkovsky at the very dawn of the 20th century, the rocket equation is the mathematical embodiment of a cruel, a recursive, and a deeply unfunny cosmic joke. It governs the fundamental and the inescapable relationship between a rocket's final change in velocity, the efficiency of its engine, its specific impulse, and the all-important ratio of its initial fully fueled mass to its final empty mass. The equation is a recursive and a self-devouring nightmare, a mathematical snake that is perpetually and ravenously and unstoppably eating its own tail. In its simplest and most direct form, it states that to achieve a certain acceleration, a rocket must expel a mass of propellant in the opposite direction, but that propellant itself has mass. So to accelerate the propellant that you are about to burn, you need to carry even more propellant. And to accelerate that additional second stage propellant, you need to carry still more propellant. For the relatively simple and inefficient chemical rockets that have successfully and gloriously taken us to the moon and to the outer planets of our own solar system, this equation is already a brutal, an unforgiving, and a demanding master. The colossal and the magnificent Saturn V rocket that sent the Apollo astronauts on their historic and their world-changing way to the moon was over 95% fuel by weight. Only a tiny, an almost insignificant, and a seemingly pathetic fraction of its 3,000-ton launch mass was the actual and the precious payload, the command module and the lunar lander that carried the 3 human astronauts. The entire rest of that magnificent and towering machine was just the fuel and the massive, the complex and the heavy tanks and engines that were required to lift the fuel. For interstellar travel, where the required final velocities are not a mere 25,000 miles per hour, but are hundreds of millions of miles per hour, the rocket equation transforms from a merely demanding and a difficult master into an absolute, a laughing, a mocking, and an utterly and completely insurmountable tyrant. Let us imagine for a moment that our far future and brilliant engineers have developed a perfect and a miraculous engine, a fusion rocket, a technology that is still for us relegated to the distant and the hazy realm of science fiction, but is in principle theoretically and physically possible. A fusion rocket, a machine that could harness the very same power of the stars themselves, would be thousands upon thousands of times more efficient than our very best and most powerful chemical rockets. Even with this miraculous and almost magical engine to accelerate a spacecraft to just 10% of the speed of light, the rocket equation dictates with an iron and an unbreakable mathematical logic that the vast, the overwhelming, and almost total majority of the ship's initial and launch mass must be composed of fusion fuel. For every single precious ton of payload, the ship itself, the crew, the life support systems, the scientific instruments, you would need to begin your journey with thousands of tons of heavy, dense, and difficult to contain fusion fuel. The ship would not be a vessel that possesses a fuel tank. It would be a colossal, a fragile, and a galaxy-sized fuel tank with a tiny, a pathetic, and an almost invisible speck of a payload that is attached almost as an afterthought to its very front. And this nightmarish and almost comical calculation assumes that you only ever want to accelerate. If you ever intend to slow down at your destination, a rather crucial and a non-negotiable step, if you don't want to streak through the target solar system like a bat out of hell in a matter of a few fleeting hours, you have to perform the monstrous, and the almost impossible acceleration in reverse. This means, with a cruel and a final twist of the mathematical knife, that you have to carry all of the fuel needed for the deceleration with you from the very beginning of the long and arduous journey. This final and unforgiving requirement squares the already impossible and almost comical numbers. The fuel that you are carrying at the start of your journey now needs to accelerate the deceleration fuel. The tyranny of the rocket equation becomes brutally and finally exponential. Even the most exotic, the most powerful, and the most efficient propulsion system that the laws of physics will allow the stuff of pure, of unadulterated, and of almost magical science fiction, an antimatter engine cannot escape this fundamental and this beautiful trap. Antimatter is the most energy-dense and the most perfect substance that is theoretically possible. When a particle of matter like a proton meets its corresponding particle of antimatter, an antiproton, they annihilate each other in a brilliant and a clean flash of pure energy, converting 100% of their combined mass into pure and usable energy in perfect and in beautiful accordance with E equals mc squared. It is the perfect and the ultimate rocket fuel. But you would still, even with this perfect fuel, need an enormous and a difficult-to-manage quantity of it. And you would still, with a final and a heartbreaking cruelty, need to carry all of the antimatter for slowing down with you. And the energy required to create just one single solitary kilogram of antimatter in a great and a powerful particle accelerator like the one at CERN is, by our current, admittedly, and grossly inefficient methods, roughly equivalent to the total and the annual energy consumption of our entire planet Earth. The rocket equation is a beautiful and elegant and a perfect brick wall of pure and of unyielding mathematics. It tells us, with a final and an absolute certainty, that any vehicle that must carry its own fuel is doomed from the very start. It is a mathematical proof that the archetypal and the beloved starship of our dreams, a self-contained, a self-powered, and a self-sufficient vessel that roams the galaxy at its will, is a beautiful, a romantic, and a complete physical impossibility. The universe has a strict and a no-baggage policy for high-speed interstellar travel, and the fuel that you so desperately need to get to your destination is the heaviest, the most cumbersome, and the most impossible baggage of all. Let us for a moment, and for the sake of our argument, suspend our disbelief and indulge in a profound and a beautiful fantasy. Let us imagine that some far future, some godlike, and some magical civilization has, by some unknown and some physics-defying miracle, overcome all of these seemingly and utterly insurmountable barriers. They have found a clever and a secret way to circumvent the absolute speed of light, perhaps by bending and by folding the very fabric of space-time itself. They have harnessed the entire and the staggering energy of their own parent star to power their magnificent and their gleaming vessel, and they have invented a magical, a massless, and an infinitely powerful fuel that has at last freed them from the cruel and the recursive tyranny of the rocket equation. They have built their magnificent and their hope-filled starship. They have selected their bravest, their best, and their most brilliant crew, and they have launched their great, their glorious, and their species-defining voyage to a distant star that is 1,000 light-years away. It is at this precise and triumphant moment that they encounter the fourth Great Wall, a barrier that is not one of physics or of engineering, but of the very nature of time itself. It is a subtle, a beautiful, and a heartbreaking barrier that transforms their heroic and their noble journey of exploration into a quiet, a profound, and an irreversible tragedy of total and of permanent social suicide. This barrier is the strange, the beautiful, and the unforgiving phenomenon of time dilation. Another of the strange, the beautiful, and the profoundly counterintuitive consequences of Albert Einstein's theory of special relativity time dilation is one of the most bizarre, the most non-intuitive, and the most rigorously and experimentally verified facts about our entire universe. Time is not, as our intuition and our daily experience so strongly and so misleadingly suggests, a universal, an absolute, and an impartial metronome, an invisible and a great cosmic river that flows at the exact same rate for everyone and for everything. Time is relative. The faster you move through space, the slower you move through time, relative to a stationary and a non-accelerating observer. For a clock on a spaceship that is traveling at a significant and a meaningful fraction of the speed of light, the seconds will tick by more slowly, the minutes will be longer, the years will be stretched than for a clock that remained behind, in the deep and the stable gravity well of its home planet. This is not a mechanical error. This is not a perceptual illusion. This is a fundamental and a non-negotiable property of the very geometry of four-dimensional space-time. The crew of the great and the fast starship is not just traveling through space, they are quite literally traveling into the deep and the unknown future of their own home world. Let us return to our fantasy ark, now capable of traveling at a blistering and a near ultimate 99.9% of the speed of light. They embark on their long and their noble 1,000 light-year journey to a promising, a beautiful, and an Earth-like planet. From the perspective of the crew who are on board the ship, thanks to the extreme and the profound effects of time dilation at this incredible velocity, the journey might take only a manageable 45 years. It is a long, it is an arduous, but it is a survivable single-generation voyage. They arrive at last at their beautiful blue-green and distant destination, and they immediately and with great joy send a powerful message back home to announce their historic and their species-altering success. That message, a coherent and a powerful beam of radio waves that is traveling at the speed of light, will take 1,000 years to reach the Earth. When it arrives, the Earth that receives that ancient and that hopeful message will be 1,045 years in the future from the moment that the ship first left its home port. But the tragedy is far deeper, far more personal, and far more profound. When the ship itself arrives at its destination from the perspective of the people who remained on the Earth over 1,000 years will have passed. The civilization that built that funded and that launched the great and hopeful ship is now a distant, a dusty, and a half-forgotten historical memory. The friends, the family, and the loved ones who celebrated its glorious departure have been dust and ashes for more than 950 years. The very language that the crew speaks may now be an archaic, a quaint, and a dead tongue. The culture, the politics, the technology, the art, the music, the very values of their home world would be as alien, as strange, and as incomprehensible to them as the ancient and the forgotten culture of the Sumerians is to us. The connection, the umbilical cord that ties a colony to its parent is irrevocably, is absolutely, and is permanently severed. The very act of high-speed interstellar travel is an act of permanent and of irreversible exile. The brave and the hopeful colonists are not a glorious extension of their home civilization. They are its forgotten and its tragic orphans. They are ghosts who are arriving in a future that has long since forgotten them and moved on. And what if they ever, in their loneliness and their nostalgia, wanted to return a 45-year journey back to the Earth from their own time-dilated perspective, would deposit them on a home planet that is now more than 2,000 years in the future from their original and their long-forgotten departure point? They would be returning not to a home, but to a museum, to an alien world, a world that has lived, has loved, has fought, has grown, and has changed without them for 2 full and transformative millennia. This profound and this unavoidable temporal schism makes any form of a cohesive, a real-time, and a functional interstellar civilization an utter and a total impossibility. There can be no trade. There can be no meaningful real-time communication. There can be no shared culture. There can be no political union. There can only be a series of scattered of, isolated, of disconnected, and of forever sundered colonies, forever separated from their parent world by the impassable, the one-way, and the heartbreaking gulf of relativistic time. It transforms the noble and the beautiful dream of exploration into a profound and a selfish act of generational and of cultural abandonment. It is a one-way ticket, not to a new and a hopeful world, but to a strange, a lonely, and a permanent state of total and of absolute temporal dislocation. Why would any sane and any rational civilization choose to inflict such a strange, such a cruel, and such a lonely fate upon its own most precious and most adventurous people? But the long and the mounting list of horrors that would be faced by the crew of our fantasy starship are not just psychological, are not just social, and are not just temporal. They are also brutally, are also relentlessly, and are also inescapably physical. Even if they could, by some miracle of psychological resilience, endure the crushing and the profound loneliness of their exile, and the deep and the disorienting temporal disconnect from their own and their only species, they would first have to survive the long and the arduous journey itself. and the vast and the cold space between the stars, the great and the dark interstellar medium, is not the gentle, the clean, and the empty void of our imagination. It is a shooting gallery. It is a cosmic microwave oven. It is a vast and a near-perfect vacuum that is paradoxically filled with a relentless and invisible and an utterly and completely lethal rain of high-energy radiation. This is the fifth Great Wall, the fifth and the final nail in the coffin of crude interstellar travel, the radiation hell of interstellar space. The primary, the most insidious, and the most unavoidable threat comes from a ubiquitous and a dangerous phenomenon that is known as galactic cosmic rays, or GCRs. These are the naked and the powerful nuclei of atoms, mostly simple protons, the nuclei of hydrogen atoms, but also the much heavier and much more damaging nuclei of elements like helium, like carbon, and like iron that have been stripped of all their orbiting electrons and have been accelerated to nearly the speed of light by some of the most violent and the most energetic events in the entire universe, such as the brilliant and the titanic explosions of supernovae, or the focused, the powerful, and the relativistic jets that are powered by the great supermassive black holes that lurk at the hearts of distant galaxies. They are tiny, they are invisible, and they are subatomic bullets, and they permeate the entire galaxy, a constant, an isotropic, and a dangerous storm of high-energy ionizing particles. Here on the surface of the Earth, we live our lives in a state of blissful and a profound ignorance of this constant and this lethal cosmic bombardment, protected by a magnificent, a multi-layered, and a planetary scale shield. Our planet's powerful and ever-present magnetic field deflects the overwhelming majority of these charged and dangerous particles, and our thick, our dense, and our beautiful atmosphere absorbs the rest. A fragile and a man-made starship in the deep and the unprotected void of interstellar space has no such protection. It is a naked, a vulnerable, and an unshielded target in a perpetual and a deadly cosmic storm. For a ship that is traveling at near relativistic speeds, the problem becomes exponentially terrifyingly and insurmountably worse. The ship is not just sitting passively in this gentle and isotropic rain of dangerous particles, it is slamming into it at an incredible and a mind-boggling velocity. From the perspective of the fragile and the biological crew who are inside the ship, the GCRs are not just a gentle and multi-directional rain. They are a high-energy, a powerful and a forward-facing beam of absolutely lethal radiation. Each individual and tiny proton, each heavy and destructive iron nucleus, strikes the hull of the ship with the kinetic energy of a macroscopic and a deadly projectile. These powerful and unstoppable particles will tear through any conventional hull material as if it were tissue paper. They will shred the delicate, the complex, and the beautiful molecular structures of human DNA, causing catastrophic, irreparable cellular damage, leading to aggressive and untreatable cancers, to irreversible cataracts, and to severe to degenerative, and to ultimately fatal neurological damage. They will systematically and relentlessly degrade the ship's most critical and most delicate electronic systems, flipping bits in the computer memories, causing the processors to fail and rendering the vital navigation and the life support systems inoperable. Over the course of a long and an arduous journey, they will slowly but surely, and with a relentless and an atomic scale precision, erode the very structural integrity of the spacecraft itself through a process that is known as sputtering. The immense and the difficult engineering challenge of adequately and effectively shielding the fragile and the human crew from this relentless and this unavoidable radiation storm is another, nearly and perhaps completely insurmountable barrier to long-duration interstellar travel. To effectively and reliably block the most energetic and the most dangerous of the heavy iron nuclei that are present in the GCR spectrum, you would need a massive and a heavy shield of matter that is many meters thick a great and a heavy cocoon that would have to completely and perfectly encase the entire habitat module. A shield that was made of lead or of water or of some exotic and a futuristic composite material would add a colossal, a prohibitive, and a self-defeating amount of mass to the ship. A 1 million ton ark might, for example, require a 10 million ton radiation shield. And this, of course, brings us right back in a full and a tragic circle to the cruel, the laughing, and the inescapable face of the tyrannical rocket equation and the monumental energy wall. The enormous and the necessary mass of the radiation shield requires an exponentially greater and a more impossible amount of fuel to accelerate, which in turn requires a civilization ending and an almost comical amount of energy to produce and to harness. The vicious, the brutal, and the self-defeating cycle is complete. Any shield that was massive enough to be effective at protecting the fragile human crew would make the ship far too massive to ever launch. Any ship that was light enough to be able to launch would be a flying and a radioactive coffin, its crew slowly, its crew surely, and its crew inevitably cooked by the relentless, the invisible, and the unforgiving fire of the interstellar medium. And even if by some profound and some unimaginable miracle of future technology and of materials, science, a perfect and a lightweight physical shield could be constructed, there is no known material and there is no conceivable technology that can shield the fragile and the evolved human mind against the profound and the almost certain psychological torment of such a long and a lonely voyage. This is the sixth great wall, the silent, the invisible, and the perhaps the most insurmountable of all the psychological cage. Human beings are the fragile, the complex, and the highly social products of 4 billion years of continuous and of uninterrupted evolution on the surface of a single, a vibrant, a dynamic, a crowded, and a beautiful planet. Our minds, our emotions, our very consciousness are not designed for, and they are not capable of withstanding millennia of perfect, of featureless, and of absolute isolation in a sterile and unchanging, a claustrophobic, and a completely artificial metal box. The immense and the unrelenting psychological stresses of a multi-generational interstellar voyage would be profound, they would be insidious, and they would be in all likelihood fatal to the mission's ultimate and long-term success. The first generation of brave and of hopeful colonists would depart with a powerful and a sustaining sense of purpose, of mission, and with a living and a beautiful memory of the Earth's blue skies, of its green landscapes, and of its teeming and its vibrant life. But what of the 10th generation, or of the 30th, a generation that was born and that was raised in the sterile, the humming and the artificial confines of the void? A generation who has never seen a real and a living sky, who has never felt the gentle touch of rain on their skin, who has never walked on solid and on living ground under an open and a warm sun. Their only and their entire reality is the monotonous and the unchanging hum of the life support systems, the taste of the recycled air, the feel of the cold metal corridors, and the cold, the unchanging, the terrifying, and the utterly alien starfield outside the viewport. How do you maintain a sense of purpose, of social cohesion, of basic fundamental sanity across 30 generations of perfect, of absolute, and of sensory-deprived confinement? The profound, the beautiful, and the life-altering overview effect, the deep and the moving cognitive shift that our own astronauts experience when they see the fragile, the beautiful, and the irreplaceable Earth hanging like a small blue marble in the vast and the black void, would be replaced over the generations by a crushing, a nihilistic, and a soul-destroying void effect. The Earth would first shrink to a faint, an unremarkable and a distant star among millions of others, and then as the ship continued to accelerate on its long and its lonely journey, it would disappear from view, entirely lost forever in the glare of its own distant sun. The crew would be utterly, they would be totally, and they would be verifiably alone, a single, a microscopic and a fragile island of organized and of living matter in an ocean of sterile, of cold and of uncaring darkness, so vast, so empty, and so profound that their own precious existence would seem like a bizarre, a meaningless and a cruel statistical error. The profound and the almost certain risk of a total social collapse of violent and of bloody mutinies born from generations of hopelessness and of confinement, of the emergence of bizarre, of irrational and of cargo cult-like religions centered on a mythical and a long-forgotten earth, or of a simple, a quiet, a collective and a generational descent into a quiet, a hopeless and a final madness would be overwhelming. We are creatures of a specific, a rich and a dynamic environment, and that environment is the earth. To remove us from it, from its sights, from its sounds, from its smells, from its rhythms, for 1,000 years is not an act of noble and of heroic exploration. It is an act of profound and of protracted torture, a psychological experiment on a scale so cruel and so inhuman that no ethical and no decent civilization would ever dream of conducting it. At this point in the relentless, the cumulative and the deeply pessimistic argument, the dedicated and the ever-hopeful advocate for interstellar travel will throw up their hands in a gesture of tactical and of temporary concession and will offer the one the seemingly obvious and the most logical alternative. Fine, they will say, crude and biological travel is impossible for 1,000 different and very good reasons. But we do not need to send our fragile, our radiation-sensitive, our psychologically unstable, and our short-lived biological bodies. We can send our robots, we can send intelligent, we can send durable, we can send patient, and we can send immortal probes. This is a sensible, a logical, and a very powerful suggestion, and it immediately and elegantly dissolves the most human-centric and the most visceral problems of time dilation, of radiation shielding for living tissue, and of the great and the terrible psychological cage. A robotic probe, a magnificent and an AI-driven emissary, does not care if its long and its lonely journey takes 10,000 years. It does not get cancer from the relentless and the unavoidable rain of galactic cosmic rays. It does not go mad from the profound and the crushing loneliness of the great and the silent void. But while the concept of sending probes is vastly, is immeasurably, and is undeniably more feasible than the concept of sending people, it does not, in the final and the most important analysis, solve the fundamental, the core and the non-negotiable problems of interstellar travel. It only serves to make them slightly less and still insurmountably impossible. This is the seventh great wall, even for our most advanced, our most intelligent, and our most patient robotic children. The journey is still far too long to be meaningful in any practical, conversational, or civilizational sense. A probe, just like a crude and a biological ship, is still irrevocably and absolutely bound by the ultimate and the unbreakable speed limit of light. It is still a helpless and a powerless victim of the monumental and the almost comical energy wall and the tyrannical and the recursive rocket equation. While we can certainly build a much smaller, a much lighter, and a much more efficient probe than a human colony ship, the energy that is required to get it to a significant and a meaningful fraction of C remains monumental and far beyond our current capabilities. The most ambitious and the most far-reaching real-world project that is currently conceived in this domain is the privately funded Breakthrough Starshot Initiative. This bold and this beautiful project proposes using a colossal, a 100 gigawatt and a ground-based laser array to accelerate a tiny, a gram-scale and a wafer-thin nanocraft that is attached to a gossamer-thin and a perfectly reflective solar sail up to an incredible 20% of the speed of light. Even this, a project that is at the very bleeding and the very extreme edge of our technological and our engineering horizon, a project that would require an energy infrastructure that is comparable to 100 large and modern nuclear power plants would still mean a long and a patient 20-year journey to our very nearest stellar neighbor Proxima Centauri, followed by a long and an even more patient 4.2-year wait for any data, for any pictures, for any sign of its successful arrival to return to the Earth. And this is for the very nearest star, our cosmic next-door neighbor. What about a star that is a mere 100 light-years away? The journey for our miraculous and our almost magical nanocraft would be 500 years, and the long and the agonizing wait for a single fleeting signal confirming its arrival would be another 100 years. We would receive a brief, and a probably corrupted postcard from a world that is 600 years in the past. This is not exploration in the way that we dream of it. This is not the great and the glorious adventure of our fiction. It is cosmic archaeology. It is a slow, a patient, a difficult, and an incredibly expensive way of learning about what other distant solar systems were like long, long ago. But it is not a way of engaging with a living, a breathing, and a dynamic galactic community. By the time that we receive a probe's signal that a distant planet is habitable, or that it even hosts a thriving and a technological civilization, the civilization that sent the probe our own might be long extinct. By the time that we could send a meaningful and a coherent reply to a signal that we might one day receive, the civilization that sent it might have destroyed itself, or it might have evolved into a form that we would no longer recognize. The vast, the empty, and the silent light years that separate the stars are not just a barrier to physical travel, they are a fundamental and an absolute barrier to conversation. They impose a communication time lag so profound, so absolute, and so disheartening that any attempt at interstellar dialogue inevitably and immediately devolves into a series of disconnected, of disjointed, and of multi-century monologues. Sending probes is a noble, a beautiful, and a worthwhile scientific endeavor. It may be the only way that we ever get a close-up and a detailed picture of a planet that is orbiting another star, but it is not a substitute for travel. It does not solve the fundamental and the heartbreaking problem of our cosmic and our profound isolation. It only serves to confirm its immense, its soul-crushing, and its inescapable scale. The probes that we might one day with a great and a heroic effort send out into the deep and the silent dark are not messages in a bottle that are sent to a waiting friend on another and a nearby shore. They are messages that are thrown into a cosmic ocean of such size and of such emptiness that they will likely never ever be found, with only the faint, the desperate, and the almost hopeless hope that some unknown and a distant intelligence 1,000,000 years from now might find the bottle washed up on the silent and the lonely shores of a long dead and a forgotten world, and might wonder for a fleeting and a curious moment who we were. It is at this point in the long, the relentless, the cumulative, and the deeply pessimistic argument, when every practical and even every wildly impractical avenue to the stars has been systematically, has been logically, and has been brutally closed off, that the hopeful and the ever-persistent dreamer will make their last, their most desperate, and their most impassioned stand. They will appeal to a higher, to a more powerful, and as yet unknown authority. They will appeal to a new, a revolutionary, and a physics that is not yet written. They will utter the two magic, the two sacred, and the two hope-filled words that have powered 1,000 of our most beloved and our most cherished science fiction stories, wormholes and warp drive. These are the great, the hypothetical, and the beautiful loopholes, the fantastical and the clever escape clauses in the ironclad and the unforgiving contract of our cosmic and our permanent confinement. They are the staples, they are the bedrock, and they are the deus ex machina that allows for the great, the glorious, and the impossible galactic empires and federations of our collective and our most cherished dreams. And they are, for the moment and perhaps forever, nothing more than beautiful, than intricate, than mathematically consistent, and than ultimately and completely unrealizable fantasies. This is the eighth great wall, the wall of speculative, of beautiful, and of almost certainly imaginary physics, a wall that promises us a key to our prison that is in all likelihood forged from pure smoke and from pure unadulterated wishful thinking. Both wormholes, which are more formally and more accurately known as Einstein-Rosen bridges, and the now famous Alcubierre warp drive, are in a narrow, a specific and a highly technical sense, theoretically and mathematically, possible. They are legitimate, they are consistent, and they are beautiful mathematical solutions to the incredibly complex, the incredibly beautiful, and the notoriously difficult field equations of Albert Einstein's theory of general relativity. They do not propose to violate the local and the absolute speed limit of light, which is, as we have established, a fundamental and an unbreakable law of nature. Instead, they propose to cheat. They propose to find a clever, a beautiful, and an elegant way around the law. They are audacious, they are brilliant, and they are mind-bending schemes for wrinkling, for folding, and for fundamentally reshaping the very fabric of space-time itself, for creating a topological and a geometric shortcut from one point in the universe to another. A wormhole would be a tunnel through a higher dimensional and an unseen space, a shortcut that would connect two distant and widely separated regions of our own universe, allowing for a journey that would take 1,000 years at the speed of light to be completed in a matter of a few fleeting minutes. An Alcubierre warp drive would work by generating a region of space-time that is violently and dramatically compressed in front of a ship and is equally and violently and dramatically expanded behind it. This would create a so-called warp bubble that would ride this self-generated and powerful space-time wave to its destination, arriving faster than light relative to its starting point, without ever locally and technically breaking the speed limit within its own small and protected bubble of flat and normal space-time. They are breathtakingly, they are beautifully, and they are intellectually seductive ideas. But they come with a catch. They come with a fine print. They come with a list of required and of non-negotiable ingredients that is so outlandish, so bizarre, and so far removed from any known and any observed physics that they may as well be a form of pure, unadulterated magic. To create, to open, and to sustain a stable, a macroscopic, and a traversable wormhole, or to generate, to control, and to navigate a warp bubble, you need a vast and a currently unimaginable quantity of something that physicists have come to call exotic matter. This is a purely hypothetical and a deeply strange form of matter that possesses a property that is known as negative mass, or more precisely, a negative energy density. It is a form of matter that would in effect possess a kind of anti-gravity. It would fall up, not down. It would push rather than pull. While the strange, the bizarre, and the counterintuitive world of quantum mechanics does allow for fleeting, for microscopic, and for virtual fluctuations of negative energy to exist in a perfect vacuum for incredibly and almost infinitesimally short periods of time, there is absolutely no evidence. And there is no good theoretical reason to believe that large, that stable, and that macroscopic quantities of such a bizarre and a physics-defying substance can or do exist in our universe. To build a warp drive that would be capable of carrying a small, a 10-meter ship, you would need a quantity of this negative energy that would be equivalent to the entire, the total, and the staggering mass energy of the planet Jupiter. To build a stable and a human-sized wormhole, you would need even more. We have no idea how to make it. We have no idea if it can be made. Most theoretical physicists strongly suspect that it is a beautiful and a tantalizing mathematical quirk, a strange and an interesting possibility that is allowed by the pure and the abstract equations, but is in reality forbidden by some deeper, some more fundamental and as yet unknown law of nature, a chronology, protection, conjecture, or some similar principle that the universe uses to prevent the temporal paradoxes, the logical absurdities, and the universe-destroying instabilities that true and unrestricted faster-than-light travel would inevitably and immediately create. To pin our hopes for a future among the stars, for a great and a glorious interstellar diaspora, on the eventual and the miraculous discovery of stable, of controllable, and of Jupiter mass quantities of exotic negative mass matter, is not a sober and a rational scientific prediction. It is an act of pure, of unadulterated, and of desperate faith. It is the modern, the technological, and the secular equivalent of a medieval and a plague-ridden peasant, a peasant who is trapped in their small and their miserable feudal village by impassable mountains and by uncrossable and stormy seas, hoping with a desperate and a fervent prayer that one day a kind and a powerful wizard will appear and will gift them a beautiful and a magical flying carpet. It is a profound and a deep confession that the known and the tested laws of physics offer us no hope, and so we must in our desperation appeal to a physics of the imagination. But the universe in its long and its beautiful history has shown itself time and time and time again to be more constrained, to be more elegant, and to be far, far less accommodating to our most cherished and our most hopeful wishes than our fantasies. The beautiful, the elegant, and the hope-filled mathematics of warp drives and of wormholes are likely, with an almost absolute and a heartbreaking certainty, to remain where they were first born on the dusty, chalk-filled blackboard, as a fascinating, as a beautiful, and as an ultimately and a completely impractical glimpse into the strange and the wonderful possibilities of a universe that could have been, but is in all likelihood, not our own. And so, after this long, this arduous, and this deeply sobering journey through the known, the tested, and the speculative laws of our universe, we find ourselves standing with a final and a weary resignation before a prison of our own and of our best comprehension. We have surveyed its great and its towering walls. We have tested their immense and their unyielding strength, and we have found them to be higher, to be thicker, and to be more intelligently and more robustly constructed than we ever in our most pessimistic moments dared to imagine. This is the ninth, the final and the real barrier, the horrifying, the beautiful, the cumulative, and the perfectly synergistic nature of all the other individual barriers combined. Interstellar travel is not impossible because of one single, easily identifiable, and perhaps one day solvable, insurmountable problem. It is impossible because it is a long, a complex, and an interconnected series of a dozen such problems, each one a formidable and an almost insurmountable fortress in its own right, and each one feeding into and amplifying and strengthening the others in a relentless, a cascading, a beautiful, and a perfectly self-defeating feedback loop of absolute and of total futility. To go to the stars, you must go incredibly, you must go mind-bogglingly fast. But the speed of light, a fundamental and an axiomatic law of causality, forbids you, with an absolute and an ironclad certainty, from ever going fast enough. To even approach that ultimate and that forever receding speed requires an amount of energy so vast, so colossal, and so totally all-consuming that it defies sanity, an energy budget that is denied to you by the simple, the elegant, and the brutal economics of E equals mc squared. To generate the incredible velocity that you need with any conceivable and any physically possible engine, you must carry a great and a heavy mountain of fuel that is so massive that it makes the ship itself impossible to accelerate in the prosum. First place, a cruel, a beautiful, and a perfect paradox that is enforced by the recursive and the unyielding tyranny of the rocket equation. If you could, by some unimaginable and some physics-defying miracle, somehow solve all of these problems, the very act of traveling at such incredible and such unnatural speeds would permanently and irrevocably sever you from your own homeworld, casting you and your descendants adrift in the deep and the lonely ocean of time, a tragic, a beautiful, and an unavoidable consequence of the strange and the wonderful phenomenon of time dilation. During this long and this lonely journey of temporal and of social suicide, your fragile and your biological body and your complex and your delicate ship would be relentlessly, would be systematically, and would be brutally scoured by a lethal, an invisible, and an inescapable storm of cosmic radiation. A storm that you cannot effectively and reliably shield against without adding so much additional and self-defeating mass that the rocket equation and the energy wall return, with a final and a triumphant laugh to mock your futile and your desperate efforts once more. And if by some miracle upon miracle upon miracle your body and your ship survive this long and this brutal onslaught, your mind, the fragile, the social, the evolved, and the uniquely terrestrial product of a single, a specific, and a beautiful world, would almost certainly and inevitably break under the unbearable and the inhuman strain of millennia, of perfect, of featureless, and of absolute isolation in the great, the silent, and the terrible psychological cage of the void. To escape this, you might in your wisdom choose to send a robot, but the robot is still too slow, its precious and its long-awaited message taking millennia to return a faint, a lonely, and an irrelevant whisper from a long-dead and a forgotten ghost. And so, in your final and your most desperate act of defiance, you might dream of bending and of folding space-time itself, only to find that the price of admission to this final and this most beautiful of all fantasies is a form of magical, of impossible, and of non-existent matter that the universe has in all of its deep and its profound wisdom likely and rightly chosen not to create. Each of these great and towering walls is a fortress. Together they form a perfect and an inescapable cage. The real and the final barrier is the beautiful and the elegant conspiracy of physics itself. The universe is not designed for travel. It is designed for confinement. The beautiful and the elegant laws of nature seem to have been precisely, and have been perfectly constructed to ensure that life, if and when it arises, stays where it began. The stars are not destinations, they are decorations. They are the beautiful, the tantalizing, and the ultimately unreachable lights on the high and the distant ceiling of our shared, our beautiful, and our permanent cosmic home. We are not a species that is on the cusp of a great, a glorious, and an inevitable interstellar diaspora. We are, and we will, in all likelihood, forever be a species of a single and a lonely solar system. We are stuck here. This is a difficult, a humbling, and for many a deeply and a profoundly unwelcome conclusion. It runs counter to our most cherished and our most deeply ingrained myths of endless progress, of manifest destiny, and of infinite and of unstoppable expansion. It feels like a failure. It feels like a cosmic grounding, a final and an unjust punishment of our entire species for a crime that we did not commit. But perhaps this is the wrong, the immature, and the unproductive way to look at it. Perhaps this dawning and this difficult realization, this sober and this mature acceptance of our permanent and our profound confinement is not an ending, but a new and a more meaningful beginning. It is the beginning of a new and a more profound kind of maturity, a new and a more sustainable kind of wisdom, a new and a more hopeful kind of civilization. For if we cannot, and if we will never be able to travel to other worlds, then the value of our own world, of this one, of this single, of this beautiful, and of this utterly and completely irreplaceable planet increases by a simple and a direct logic to infinity. This is the final, and the most profound and the most important implication of the functional and the practical impossibility of interstellar travel. The Earth is not our cradle, a planetary nursery from which we are destined one day to graduate and to move on. It is our final destination. This profound and this necessary shift in our collective perspective is the most important one that our species may ever have to make. It forces us with a gentle but a firm hand to abandon the adolescent, the dangerous, and the ultimately self-deluding fantasy of escaping our own, our local, and our self-inflicted problems by finding a new and a better home. There is no planet B. There is no pristine, there is no empty, and there is no conveniently located second Earth waiting for us just a few short light years away. We cannot ruin this world through our own short-sighted greed and through our own foolish divisions, and then simply and conveniently pack our bags and move on to the next one. This is it. This is the whole and the final inheritance. Our ultimate destiny is not written in the distant and the silent stars. It is written here. It is written now, in the soil, in the water, and in the air of this, one of this single and of this irreplaceable planet. Our great, our noble, and our multi-generational project is not the conquest of the galaxy, but the stewardship, the preservation, and the celebration of the Earth. Our long-term future will be determined not by the speed and the power of our starships, but by the depth and the breadth of our wisdom, of our compassion, and of our cooperative actions right here, right now, in this critical, this fleeting, and this precious moment of our history. This profound and this sobering realization does not need to be a source of despair, of nihilism, or of cosmic gloom. It can be, and it must be a source of profound, of unifying, and of urgent purpose. It imbues our world and our life upon it with a kind of a sacredness, a preciousness, and an importance that no myth or no religion has ever before conceived. We are living on the most valuable, the most precious, and the most important piece of real estate in the entire galaxy, and perhaps in the entire known universe. It is a living, it is a breathing, and it is a thinking oasis of almost impossible luck in an endless, a sterile, and a hostile desert of frozen rock and of lethal radiation. To be born here, to be alive now, is to have won a lottery with odds so great and so astronomical that they are for all practical purposes indistinguishable from a deliberate, a benevolent, and a beautiful miracle. Our duty, our single, our great, and our multi-generational purpose is to protect the prize. It is to build a civilization that is as stable, as enduring, as just, and as beautiful as the planet that against all odds gave it birth. The great and the profound silence from the stars is not a mystery that needs a solution. It is a lesson that needs to be learned. The reason that we hear no one is because the universe is by its very physical design a collection of lonely, of beautiful, and of isolated islands of life, each one trapped as we are within the confines of its own solar system, each one facing the same, the ultimate, and the binary choice to learn to live in a lasting and a sustainable harmony with its own, its single, and its finite world, or to perish. We are not alone in our great and our difficult challenge. We are only alone in our final and our ultimate outcome. The future of the human story will not be a grand, a glorious, and a sprawling epic that is written across 1,000 different star systems. It will be an intimate, a difficult, a challenging, and a beautiful drama. A drama that will be played out in its entirety on this one, this small, this fragile, and this infinitely precious and irreplaceable stage. Our final and our true frontier is not the empty and the uncrossable space between the stars. It is the challenging, the difficult, and the yet-to-be-crossed space between ourselves. And our greatest and our most noble exploration will not be the charting of new and of distant worlds, but the charting of a sustainable, of a peaceful, and of a meaningful future, right here on the only home that we, or that any of our descendants will ever know. The physics of the universe does not invite us to become its neighbors. It commands us with a final and a beautiful authority to stay home. A dish of polished metal 100 meters wide pivots silently in a quiet valley in West Virginia. It is a steel sentinel cupped toward the heavens listening. This is the Green Bank Telescope, one of the twin ears of a grand experiment. Its counterpart, the Parkes Observatory, performs the same patient vigil under the southern stars of Australia. For 10 years, these colossal instruments and others like them have been engaged in the most comprehensive search for intelligent life ever undertaken. They are not waiting for a greeting, they are hunting for ghosts. They are sifting the cosmic static for the faintest, most fleeting whisper of a signal that is not born of nature. They are scanning for a single anomalous note in the universe's chaotic symphony, a sound that betrays the presence of a mind. $100 million has been wagered on the idea that somewhere in the dark, another consciousness is leaving a trace, an ethereal echo of its existence. After a decade of pointing these immense ears at the sky, after inspecting 1 million nearby stars and 100 nearby galaxies, the return has been an unbroken, profound silence. 0 voices have called back from the void. The project launched in 2015 with the backing of the philanthropist Yuri Milner, represented a paradigm shift in the search for extraterrestrial intelligence. It was a move away from sporadic, underfunded efforts and toward a systematic, relentless survey of the sky. The sheer scale of the endeavor is difficult to comprehend. The telescopes scan a vast range of the radio spectrum from hundreds of megahertz to tens of gigahertz. This is the quiet celestial window where natural noise from cosmic sources is at a minimum a region long hypothesized to be the ideal channel for interstellar communication. The data collected by these instruments is a deluge, a torrent of information measured in petabytes. Every day, the project generates more data than the entire history of radio astronomy that preceded it. It is an act of listening on an industrial scale, a testament to the power of modern computation and the persistence of human curiosity. We have built the most sensitive listening devices in history and pointed them at our nearest cosmic neighbors. We have strained to hear the faintest sign of technology, the ghost of a machine on a distant world. The targets are chosen with care. The primary list consists of the 1 million closest stars to Earth. These are our immediate neighbors in the galactic suburbs. Light and any signal traveling with it would take only years or decades to cross the distances between us. If a civilization exists around one of these stars, it is close enough that a conversation spanning generations might be possible. The survey also includes the 100 nearest galaxies. This is a more speculative search, a cast of the net into deeper waters. A signal from the Andromeda galaxy would have been traveling for 2.5 million years. It would not be a message, it would be an artifact, a fossilized sound from a civilization that could be long extinct. Such a signal would have to be incredibly powerful to be detectable, the product of a civilization far beyond our own capabilities, one that could perhaps harness the energy of its entire galaxy. The search therefore operates on 2 levels, a hopeful scan for neighbors and an archaeological dig for ancient, powerful ghosts. But the universe is not a quiet place. It is filled with natural radio sources, a cacophony of violent and exotic phenomena. Pulsars, the rapidly spinning corpses of massive stars, sweep beams of radiation across the cosmos like cosmic lighthouses. Their signals are precise, rhythmic, and powerful. When the first pulsar was discovered in 1967, it was jokingly labeled LGM-1 for Little Green Men. It was the first ghost signal, a pattern so regular it seemed artificial until its natural origin was understood. Today we know of thousands of pulsars, They are part of the background noise that the search must filter out. Quasars, the intensely bright cores of distant galaxies powered by supermassive black holes, are another source of powerful radio emission. Gas clouds, stellar flares, and the faint afterglow of the Big Bang itself all contribute to the cosmic static. The challenge of Breakthrough Listen is to find a needle of artificiality in a haystack of natural noise the size of a galaxy. It is a search for a signal that is fundamentally different from all the other sounds of the universe. The raw data from the telescopes is just the beginning of the process. The real work is done by the algorithms. A river of data flows from the receivers into a powerful supercomputer, a signal processor that performs trillions of calculations per second. This digital brain sifts through the noise looking for the telltale signs of technology. What does a ghost signal look like? The primary characteristic it seeks is a narrow-band emission. Natural astrophysical sources tend to emit radiation over a broad range of frequencies. A radio station on Earth, by contrast, broadcasts on a very specific narrow frequency. The assumption is that an alien civilization would use a similar method to transmit information efficiently. A narrow-band signal is an indicator of technology. It is a sound that nature, as far as we know, does not make. The algorithms are programmed to hunt for these slivers of order in the broad-spectrum chaos. The software also looks for other signs of intelligence. It searches for signals that drift in frequency, a potential sign of the Doppler effect caused by a transmitter on a rotating orbiting planet. It looks for repeating patterns, pulses that might encode information. It looks for signals that are polarized in a way that suggests an artificial origin. Every day, the system flags millions of potential signals of interest. These are the first-level ghosts, the momentary flickers of possibility in the data stream. But the vast majority of these are quickly identified and discarded. They are the echoes of our own technology. A satellite passing overhead, a stray signal from a mobile phone, a distant radar system, even a microwave oven in a telescope facility's kitchen can all create false positives. The Earth is a noisy planet, and shielding the telescopes from our own technological chatter is one of the project's greatest challenges. The search for alien ghosts is haunted by the ghosts of our own machines. After a decade of this relentless scanning, the results are unambiguous. Billions of candidate signals have been detected and analyzed. Tens of thousands have been subjected to more detailed scrutiny. But in every single case, the signal has been traced back to a natural source or to human-generated interference. Not one signal has survived the rigorous verification process. The silence is not for a lack of trying. We have built the ears, and we have listened with an unprecedented intensity. The sky has simply refused to speak. This is a profound and perhaps unsettling scientific result. It is a null result, but a null result of historic significance. It tells us that our local stellar neighborhood is not filled with powerful, obvious radio transmitters. The easy-to-find civilizations, the ones broadcasting loudly on the most logical frequencies, are not there. The ghosts are more elusive than we thought, or they are not there at all. This decade of silence deepens the mystery of the Fermi paradox. The galaxy is old and vast, filled with potentially habitable planets. By all rights, it should be teeming with life, and at least some of that life should have developed technology. Yet we find nothing. The work of Breakthrough Listen has transformed this paradox from a philosophical parlor game into a hard observational constraint. We are not just speculating about the silence anymore. We are measuring it. We are placing limits on the number and power of potential civilizations in our corner of the galaxy. Every star that is scanned and found to be quiet adds another data point to the great silent scoreboard. The universe we are revealing is a wilder, emptier, and more mysterious place than many had hoped. It is a universe where minds, if they exist, are either very rare, very quiet, or very different from us. The search for ghost signals has so far only revealed the profound and pervasive ghostliness of the cosmos itself. a beautiful, complex, and seemingly uninhabited expanse. The search is not limited to the radio spectrum. A parallel effort known as optical SETI scans the sky for another kind of ghost signal, brief, powerful flashes of laser light. The logic is compelling. A laser can be focused into a tight beam, allowing a signal to be sent across interstellar distances with much less power than an omnidirectional radio broadcast. A sufficiently advanced civilization might use a colossal laser array to send flashes of information to targeted star systems. These would be lighthouses in the cosmic dark, deliberate beacons intended to attract attention. To detect such a signal, telescopes are equipped with photometers, high-speed cameras that can register a brief spike in brightness from a single star. The challenge here is similar to the radio search to distinguish a potential artificial flash from the zoo of natural variable stars. Cosmic ray hits on the detector and glints from orbiting satellites. So far, the optical search, like the radio search, has found no confirmed signals. The sky is not just quiet, it is dark. As we stand at the 10-year mark, the grand experiment of Breakthrough Listen forces us to confront the reality of our cosmic isolation. The $100 million bet has not yet paid off. The ears we have built have heard only the wind and the rain of natural cosmic processes. The ghost signals we have chased have all turned out to be mirages, but the project is far from over. The data continues to pour in. The algorithms are constantly being improved. New telescopes are being added to the network. The decade of silence is not an end, but a beginning. It is the first comprehensive chapter in a much longer story. It is the baseline measurement against which all future searches will be compared. We have established with a new level of certainty the depth of the silence we are trying to break. The question now is what we do with this knowledge. Do we interpret the silence as a sign of absence and give up? Or do we see it as a challenge to listen harder, to search in new ways, and to refine our understanding of what a ghost signal might truly be? The silence is a canvas, and the next decade of searching will paint a new, more detailed picture of its texture and its meaning. The very concept of a signal is a construct of our own intelligence. We are searching for patterns that we would recognize as artificial, a form of cosmic communication that mirrors our own technological development. The archetypal signal we seek is a carrier wave, a pure tone at a specific frequency, which is then modulated to carry information. This is how radio on Earth works. We might vary the amplitude of the wave, its frequency, or its phase, to encode a series of ones and zeros. A narrowband signal is the carrier wave, the dial tone of the galactic telephone. We listen for this tone because it is an efficient way to transmit information over long distances, and because it is a clear sign of technology. A signal with a bandwidth of just 1 Hz is a beacon that stands out starkly against the broadband hiss of natural sources. It is a sound so pure, so orderly, that it seems to demand an explanation beyond astrophysics. It is the ghost of a perfect sine wave haunting the noisy spectrum. But this assumption that an alien signal would resemble our own technology is a profound and perhaps limiting one. An intelligence 1,000,000 years more advanced than ours might have discovered methods of communication that are far beyond our comprehension. They may not use electromagnetic waves at all. They might communicate using modulated neutrino beams, gravitational waves, or some form of physics we have not yet discovered. In this case, our radio telescopes would be as useless as trying to detect a fiber optic signal with an ear trumpet. We could be bathed in a flood of alien information, a constant stream of complex communication, and be completely unaware of it. The silence we perceive would be a silence of our own incomprehension, the result of a profound mismatch in technology and perception. We are listening for ghosts with a flashlight when they may only be visible in the dark. Even if they do use radio waves, the signal itself might be indistinguishable from noise to our current algorithms. A civilization seeking to transmit the maximum amount of information in a given bandwidth would use sophisticated compression techniques. According to information theory, a perfectly compressed message is one where all the redundancy has been removed. Such a message would be mathematically indistinguishable from random noise to any receiver that does not possess the key to decompress it. An advanced civilization might be broadcasting a signal that fills its entire allocated bandwidth, a message so rich with data that it appears as a smooth, featureless hiss. It would be a ghost hiding in plain sight, its artificiality masked by its own efficiency. Our search for simple narrowband beacons might be like searching for a message written in smoke signals in an age of encrypted digital streams. The journey of a signal across interstellar space would also alter its characteristics, potentially disguising it. The vast distances are not a perfect vacuum. They are filled with a tenuous plasma of charged particles. As a radio wave travels through this plasma, it is dispersed. Different frequencies travel at slightly different speeds, causing a sharp pulse to be smeared out in time. Higher frequencies arrive slightly earlier than lower frequencies. Our search algorithms are designed to correct for this dispersion, to de-smear the signal and reconstruct its original form. But this correction depends on knowing the distance the signal has traveled. An incorrectly de-smeared signal might be missed entirely. The signal is a ghost whose form is distorted by its long journey through the cosmic fog. Furthermore, the signal would be incredibly weak. The intensity of a radio broadcast decreases with the square of the distance from the source. A signal from a star 100 light-years away would be 10,000 times weaker than a signal from a star 10 light-years away. By the time it reaches our telescopes, a signal from even the nearest stars would be billions of times weaker than the signals from our own communication satellites. Detecting such a faint whisper requires incredible sensitivity and the ability to average a signal over a long period of time to lift it out of the background noise. This is one of the primary reasons for the scale of breakthrough. Listen to stare at a single target for long enough that a faint, persistent ghost might emerge from the static. But if a signal is intermittent, if a civilization only broadcasts for a short period of time, we would have to be incredibly lucky to be listening at the right time and in the right direction. The sky is vast and our listening posts are small and few. We are trying to catch a ghostly firefly in a dark forest the size of a continent. Optical signals face their own set of challenges. While a laser beam is highly directional, it is not perfect. It will still spread out over interstellar distances. A beam aimed at our solar system from 100 light-years away would have spread to a size many times larger than the Earth's orbit. Only a tiny fraction of the original light would enter our telescopes. The signal would also have to contend with absorption and scattering by interstellar dust. And of course, the sender would have to know precisely where we are and aim their laser with pinpoint accuracy. This requires them to have detected our solar system and perhaps even the signs of life on our planet. An optical signal is less of a broadcast and more of a targeted personal message. The absence of such signals could mean that no one is trying to contact us specifically. The ghost is not calling our name. A new and intriguing possibility has emerged with the discovery of fast radio bursts, or FRBs. These are incredibly bright, millisecond-long bursts of radio waves that appear to be coming from distant galaxies. Their origin is one of the biggest mysteries in modern astronomy. The leading natural explanation is that they are produced by magnetars, a type of neutron star with an extremely powerful magnetic field. But their strange repeating patterns and immense power have led some to speculate that they could be artificial. Could FRBs be the ghost signals of a Type 3 civilization? Perhaps they are the energy leakage from the light sails of a fleet of interstellar spacecraft, the exhaust fumes of a galactic transportation network. Or perhaps they are deliberate galaxy-spanning beacons designed to be seen from billions of light-years away. The Breakthrough Listen project is now dedicating a significant amount of its observing time to monitoring known FRB sources, hoping to find a complex, information-rich structure within the bursts. So far, none has been found. The ghost remains a simple, powerful, and enigmatic flash. Let us consider the 10 leading candidate signals that the project has investigated over the past decade. Each one represents a moment of intense excitement and possibility, a brief period where it seemed the silence might have been broken. The most famous of these was BLC-1, a narrowband signal detected in 2019 that appeared to be coming from the direction of Proxima Centauri, the closest star to our Sun. The signal persisted for several hours. It drifted in frequency in a way that was consistent with a source on an orbiting planet. It occupied a very narrow slice of the radio spectrum, a characteristic that is difficult to explain with natural astrophysics. For months, the team worked in secret to verify the signal, trying every possible way to show that it was just our own interference. It was the most promising ghost signal in the history of SETI. Eventually, however, the source was identified. The signal was traced to a specific type of radio frequency interference on the ground, a ghost born not in the stars but in human electronics. This story has been repeated in less dramatic fashion for every other significant candidate signal. A signal from the star Ross 128 was found to be the transmissions from a geostationary satellite. Other signals have been traced to military radar, distant aircraft, and a host of other terrestrial sources. The process of verification is a process of elimination, a painstaking act of cosmic detective work. The default assumption is always that the ghost is one of our own making. Only a signal that survives every attempt at debunking one that is detected independently by multiple observatories, and one that repeats in a predictable way, would be considered a true candidate for an extraterrestrial intelligence. The bar for evidence is, and should be, extraordinarily high. A false positive would be a scientific embarrassment of the highest order. A confirmed signal would be the most important discovery in human history. The 10-year scoreboard is not just a record of silence, it is a record of the rigorous, self-critical nature of the scientific process. Every ghost has been successfully exercised. The next generation of telescopes will provide a new level of sensitivity that could change this story. The Square Kilometre Array, or SKA, is a planned network of thousands of radio dishes in South Africa and Australia. When completed, it will be the largest and most sensitive radio telescope in the world. It will be able to survey the sky thousands of times faster than current instruments and detect signals that are much fainter. The next generation Very Large Array, or NGVLA, in the United States will offer a similar leap in capability. These new observatories will be able to map the radio sky with a resolution and depth that is currently unimaginable. They will be able to detect the faint radio leakage of a civilization like our own from tens of light years away. They will be able to conduct a search for ghost signals that is orders of magnitude more comprehensive than what Breakthrough Listen has been able to achieve. This is the next round in the fight between the searchers and the silence. But even with these powerful new tools, the fundamental challenge remains. We are searching for a ghost of our own imagining. We are looking for a signal that conforms to our understanding of physics, our theories of information, and our assumptions about the behavior of intelligent life. It is entirely possible that we are looking for the wrong thing in the wrong place with the wrong tools. The first decade of Breakthrough Listen has been a humbling experience. It has shown us the vastness of the haystack and the elusiveness of the needle. It has forced us to confront the possibility that the universe is not just quiet, but silent. The search for ghost signals is a search for a meaning that we hope is embedded in the cosmos, a sign that we are not alone in our brief moment of consciousness. The story of the next decade will be written by the data from these new machines. They will either deepen the silence, making our isolation even more stark, or they will finally detect the whisper of a ghost, and change the world forever. The heart of the search is a computational engine of immense power. The torrent of data from the telescope's receivers is fed into a machine designed for a single purpose: to find patterns. An artificial intelligence, armed with a suite of sophisticated algorithms, stands as the gatekeeper between the noise of the cosmos and the attention of human scientists. This AI is the true listener of the project. A human being could not possibly sift through the petabytes of data that are collected each day. We have outsourced our sense of cosmic hearing to a silicon brain. The AI is trained on what we expect a signal to look like: a narrow band, a Doppler drift, a repeating pulse. It is a tireless hunter scanning billions of frequency channels every second, looking for a ghost that matches the description we have given it. It is a search for a specific kind of order, the kind of order that we, as tool builders and engineers, tend to create. This process raises a deep philosophical question. Are we programming the AI to find alien intelligence, or are we programming it to find a reflection of ourselves? Our definition of an artificial signal is inherently anthropocentric. It is based on the technologies we have developed and the principles of efficiency that govern our engineering. A truly alien intelligence with a different evolutionary history, a different neurobiology, and a different mathematics might create signals that are completely invisible to our algorithms. Their technology might produce a form of order that we would perceive as chaos. Their ghost might have a shape we are not equipped to see. We are like fishermen using a net with a certain size of mesh. We can only catch the fish that are larger than the holes. We are blind to anything that is smaller or that has a different shape. The silence we have recorded over the past 10 years might be the sound of a universe filled with creatures that slip right through our net. The search for ghost signals is, in essence, a search for a departure from the natural. We must first have a complete and comprehensive understanding of all the ways the universe can produce electromagnetic radiation. Every new astrophysical discovery, from pulsars to FRBs, adds another piece to this catalogue of natural phenomena. Each of these was, for a time, a ghost signal, a mystery that defied easy explanation. Science works by peeling away these layers of mystery, replacing them with physical understanding. The SETI project is operating at the very edge of this process. It is looking for a phenomenon that cannot be explained by any known astrophysics. It is a search for a signal that would force us to invent a new category of existence, the technological. To claim such a discovery would require ruling out every other possibility, no matter how exotic. The ghost must be shown to be something other than a previously unknown form of cosmic weather. This is why the sifting process is so rigorous. When the AI flags a candidate signal, it enters a pipeline of verification. First, the signal is checked against a database of all known human-generated interference. Is it at a frequency used by a known satellite or a ground-based transmitter? Was it detected when the telescope was pointed at a specific target? Or does it seem to be present no matter where the dish is looking? The off-source observation is crucial. The telescope will point away from the target star for a period of time. If the signal is still present, it is almost certainly local interference. The ghost must disappear when you look away. This simple test eliminates more than 99% of all candidate signals. The vast majority of the ghosts that haunt the machine are born on Earth. If a signal passes this first filter, it is then subjected to a battery of further tests. Does it appear in data from multiple independent telescopes? A true celestial signal should be detectable by any instrument with sufficient sensitivity that is pointed at the right place at the right time. Has it been seen before? Does it repeat? A one-off signal is intriguing, but it is impossible to verify. A repeating signal would be a smoking gun. It would allow for detailed study and for other observatories around the world to confirm the detection. This is the holy grail of the search: a persistent, verifiable and unambiguously artificial signal from a fixed point on the sky. The 10-year history of Breakthrough Listen has been the story of this verification pipeline in action. It is a machine for destroying ghosts, for turning tantalizing possibilities into mundane explanations. Its success is measured not by the ghosts it finds, but by the thoroughness with which it lays them to rest. The case of fast radio bursts illustrates the ambiguity at the heart of this search. These millisecond-long bursts are undeniably real. They are not interference. They are powerful celestial events. But are they natural or artificial? The debate rages on. Some FRBs have been observed to repeat, but not with a simple regular pattern. Their spectrum is complex. They are the perfect ghost signal, a phenomenon that is real, mysterious, and just on the edge of what we might imagine a piece of alien technology to be. If FRBs are natural, they are pointing to some new and exciting astrophysics, a new way for matter and energy to behave in the most extreme environments. If they are artificial, they are a sign of a civilization so powerful that its daily activities are visible across billions of light years. Breakthrough Listen's monitoring of FRBs is a direct attempt to resolve this ambiguity. By capturing thousands of bursts from a single source, the project hopes to find a deeper layer of structure, a message hidden within the seemingly random flashes. It is an attempt to see if this particular ghost has a mind behind it. The AI is also being trained to look for new kinds of signals to expand the size of its net. Machine learning techniques are being used to allow the AI to search for anomalies without being told exactly what to look for. The system can be trained on a vast dataset of known natural signals and human interference. It can then be asked to identify anything that does not fit into these categories, anything that is truly other. This is a more open-minded approach to the search, an admission that we may not know what a ghost signal will look like. It is a search for the unknown unknowns. This is the frontier of the project, where the boundary between signal processing and artificial intuition begins to blur. We are trying to build a machine that is not just a listener, but a discoverer, an AI with a sense of cosmic curiosity. Despite these technological advances, the fundamental problem of evidence remains. What would it take to convince the scientific community and the world that we have detected a signal from another intelligence? A single narrowband tone from the direction of a sun-like star would be a start. If that tone repeated and was confirmed by other observatories, the level of interest would be immense. But it would still not be proof of intelligence. It would be proof of a non-natural transmitter. It could still be some unknown physical process. To prove intelligence, we would need to find information in the signal. We would need to detect a complex modulation, a pattern that could not reasonably be expected to occur by chance. The ultimate proof would be the decoding of a message. But this is a task of immense, perhaps insurmountable difficulty. We would not share a common language, a common biology, or a common frame of reference. The signal would be a ghost, and we would be trying to understand its language without a dictionary or Rosetta Stone, for a world we have never seen. The 10 years of scanning have produced no such signal. The evidence check is stark. There have been no real hits, no candidate signals that have survived the scrutiny of the verification pipeline. The project has successfully identified and catalogued thousands of new sources of terrestrial interference. It has produced the most comprehensive survey of the radio silence in human history. It has set the most stringent limits yet on the prevalence of technological civilizations in our galactic neighborhood. These are important scientific achievements, but they are not the achievement the project set out to make. The breakthrough remains elusive. The silence remains unbroken. The scoreboard after round 1 reads, "The Great Silence, 1 Humanity, 0. The next generation of telescopes and AI algorithms represents our hope for round 2. But we must be prepared for the possibility that the silence is not a temporary state but a fundamental feature of the cosmos we inhabit. The ghosts we are hunting may not exist. The silence has a weight. A decade of listening with nothing to show for it can be demoralizing. It gnaws at the assumptions that have fueled the search for decades. The core idea behind SETI is the principle of mediocrity, the idea that there is nothing special about the Earth, our Sun, or ourselves. If life and intelligence arose here, they should have arisen in countless other places. The universe should be filled with voices. But the evidence from Breakthrough Listen points in the opposite direction. It suggests that we may in fact be special. We may be rare or even unique. This is a philosophical shift with profound implications. If we are alone, then the responsibility for the future of consciousness in this galaxy rests entirely on our shoulders. The silence is not just an absence of signals, it is an absence of peers, of elders, of any other mind to share the burden of existence with. This leads to the various interpretations of the silence, the grand hypotheses that attempt to explain the missing ghosts. The Great Filter theory suggests that there is some evolutionary or technological step that is so difficult to overcome that almost no species ever makes it. The silence is the sound of universal failure. The filter could be in our past, meaning we are one of the lucky few who have survived it. Or it could be in our future, a looming test that we are about to face. Breakthrough Listen in this context is a form of cosmic reconnaissance, an attempt to see if anyone else has made it through the minefield that lies ahead. The empty sky is a worrying sign. It suggests the minds are very effective. We are listening for the voices of survivors in a graveyard. Another possibility is the dark forest hypothesis drawn from the science fiction of Liu Cixin. In this model, the universe is teeming with life, but it is a life that has learned to be silent. The galaxy is like a dark forest filled with hunters. The only survival strategy is to stay hidden. Any civilization that makes itself known by broadcasting signals is immediately targeted for destruction by older, more paranoid civilizations. It is a universe where the law of the jungle applies on a cosmic scale. In this scenario, Breakthrough Listen is an incredibly naive and dangerous act. We are shouting into a forest where predators are listening. The silence is not an absence of life, but a carefully maintained camouflage. The ghosts are silent because they are afraid. If this hypothesis is correct, we should hope that our search continues to find nothing. Then there is the transcension hypothesis. This idea posits that advanced civilizations do not expand outward into the universe, but inward into a computational reality. They might build a planet-sized computer, a matryoshka brain, and upload their consciousnesses into a simulated paradise. From this point on, they would have no need or desire to communicate with the messy, slow, and dangerous physical world. They would effectively disappear from the universe, leaving behind only a silent, compact supercomputer. The silence we observe is the sound of civilizations graduating from our level of reality. They are not dead. They have simply moved on. The ghosts are not in our world anymore. They have become the gods of their own private digital heavens. This is a more optimistic, if lonely, explanation for the silence. The evidence from the past 10 years of scanning does not allow us to distinguish between these possibilities. The silence is consistent with all of them. We are left with a profound uncertainty about our place in the cosmos. Are we the first, the last, or just the most foolish? The data from Breakthrough Listen has sharpened the horns of this dilemma. We can no longer comfort ourselves with the thought that we simply have not looked hard enough. We have now looked very hard. We have conducted a search of unprecedented scale and sophistication. The fact that we have found nothing makes the silence a more pressing and significant mystery than ever before. It is the central mystery of our time. The project itself is a testament to a uniquely human quality hope in the face of overwhelming odds. To spend $100 million and a decade of scientific effort on a search that has a high probability of finding nothing is an act of profound optimism. It is a statement that the potential reward, the discovery of another mind in the universe, is worth the risk of disappointment. It is a refusal to accept loneliness as the final answer. The search for ghost signals is as much a psychological and philosophical endeavor as it is a scientific one. It is a mirror in which we see our own hopes and fears about our place in the universe. We are listening for them, but we are also learning about ourselves. The lack of any real hits so far forces a re-evaluation of our search strategy. If the powerful, obvious beacons are not there, then perhaps we need to look for more subtle signs. We might look for the faint leakage from a civilization's planetary radar systems or navigation beacons. We might look for the industrial pollution in the atmospheres of exoplanets, the chemical ghosts of a technological society. We might look for artifacts in our own solar system, the probes of a long-dead galactic empire. The search may need to become broader, more patient, and more creative. The ghosts may not be shouting, they may only be whispering, and we will need a new kind of ear to hear them. The 10-year milestone of Breakthrough Listen is a moment for reflection. It is a time to take stock of what we have learned and to consider the path forward. The scoreboard is not encouraging. The silence is deeper and more profound than we knew. The universe seems to be stubbornly resistant to our attempts to find a companion. But the story is not over. The next generation of instruments will open up new frontiers. The AI sifting the data will become smarter. Our understanding of the universe will continue to grow. The search is a marathon, not a sprint. A decade is a long time in a human life, but it is a cosmic eye blink. We have only just begun to listen. The ghosts may still be out there waiting in the static, their faint signals drowned out by the noise of a universe that has not yet revealed all its secrets. What does the act of listening do to the listener? For 10 years, a dedicated community of scientists and engineers has been immersed in the cosmic silence. They have chased down countless false alarms, spent sleepless nights analyzing candidate signals, and have time and again come up empty. This process could lead to cynicism and despair, but instead it seems to foster a sense of profound humility and a deep appreciation for the fragility of our own existence. To spend one's life searching for another mind is to be constantly reminded of the preciousness of our own. The silence from the stars makes the sounds of our own world. The voices, the music, the laughter seem infinitely more valuable. The search for extraterrestrial intelligence is one of the most powerful tools we have for cultivating a planetary consciousness, a sense of ourselves as a single, fragile species on a small blue world. The project also forces us to confront the vastness of time. A signal from a star 1,000 light-years away would be a message from a civilization as it existed in the Middle Ages on Earth. We would be receiving a ghost from the past. A response would take another 1,000 years to arrive. Any conversation would be a dialogue between distant generations, a slow, patient exchange of information across the millennia. This reframes our own civilization in a grander temporal context. Our current political and social concerns, which seem so urgent, are revealed to be fleeting moments in a much longer story. The search for ghost signals is an investment in a future that we will not live to see. It is a gift to our descendants, an attempt to start a conversation that they might one day finish. It is an act of faith in the continuity of human civilization. So what is the path forward? Do we continue to scan, or do we give up? To give up would be to accept the silence as final. It would be to turn our back on one of the most profound questions we can ask. It would be an act of intellectual surrender, an admission that we are content to live in a state of cosmic ignorance. It would be to let the ghosts, if they exist, remain ghosts forever. The alternative is to press on, to build the bigger telescopes, to design the smarter algorithms, to search in new ways and on new wavelengths, to accept the silence of the first decade not as a failure but as the necessary groundwork for the discoveries of the next. To continue the search is to keep hope alive. It is to hold on to the possibility that the universe is more interesting, more wonderful, and less lonely than it currently appears. This choice is not just a matter of scientific policy, It is a reflection of our character as a species. Are we a species that is content with the answers we already have, or are we one that is driven to explore the unknown? Are we defined by our limitations or by our aspirations? The Breakthrough Listen project, despite its null results, is a powerful statement of aspiration. It is a monument to our curiosity. It is a $100 million bet that the universe is not a sterile, meaningless void, but a place filled with a potential for wonder that we have only begun to tap. It is a declaration that even if we are alone, we will live as if we are not. We will keep the channel open. We will continue to listen. The next 10 years of the search will be crucial. With the Square Kilometre Array and other new instruments, we will expand the volume of space we have surveyed by a factor of 1,000 or more. If there are civilizations out there with technology similar to our own, we will have a much better chance of finding them. If the silence persists even after this next deeper phase of listening, then the conclusion that we are alone in our galaxy will become much harder to avoid. We are approaching a moment of truth, a point where our philosophical speculations about our place in the universe will be replaced by a hard observational answer. We are on the verge of knowing whether the ghosts are real or not. But even if the answer is a definitive no, the search will not have been in vain. The technology developed for SETI has had numerous applications in other fields, from radio astronomy to signal processing. The project has inspired millions of people and has brought the scale and wonder of the cosmos into the public consciousness. And most importantly, it has held up a mirror to ourselves. In the silent reflection from the cosmic void, we have been forced to see our own civilization with a new clarity, its brilliance, its fragility, its potential, and its profound, unconfirmed solitude. The search for ghost signals is a journey that is worth taking, regardless of the destination. It is the story of a young species reaching out into the vast, silent night, and in the act of reaching, discovering the true measure of its own small, warm hand. The final verdict on whether to keep scanning is not a scientific one. It is a question of who we want to be, and the answer for now seems to be, we are the species that listens. And so the scanning continues. The dishes turn, the data flows, and the tireless, hopeful hunt for a single intelligible ghost in the grand silent machine of the universe goes on.